everyone. My name is Anushri.
I'm Ishan Kushwaha.
Today we are here to present a project on house price prediction. So coming to our problem statement. So objective of our project is to predict the sales price of the house based on the particular futures. So these are the data features. So we have taken our data set from the Kaggle, which contains about 1460 training data points and 80 features.
These are the data descriptions. So we have used the business libraries. First is the pandas. Pandas is used for the data manipulation and analysis.
Next is a NumPy, which is used for mathematical operations on large and multidimensional arrays and matrix.
And Matplotlib is used for data visualization for displaying the 2D and 3D plots.
Next is a Seaborn, which is based on a matplotlib but for plotting statistical graphics.
Then the train test split. It's used to split the data into train data and test data.
Next is the mean square error, where we are used to calculate mean square error based on the particular models. Next will be the linear regression model. Linear regression model is a fundamental statistical model where we are going to predict the values based on the independent and dependent values.
Then XGBoost, it's used for implementation of the gradient boosting decision tree, and it's used to understand the data and to make better decisions. And the randomized search CV is used for passing the set of hyperparameters to calculate the score and give us the best set of parameters for making model the best accuracy.
Next is a decision tree regressor, which perform regression tasks based on the tree-like structure to predict a continuous target variables on various features.
Then there's set options we have done for displaying in the Google Colab for the display.max columns and display.max rows. Then we have read train data with .read CSV, and .head is used for displaying the top 5 rows of our data. And in train data we have we have 1460 rows and 81 columns. And data types, it's not run. We have categorical variables also and numerical variables also in our data. Missing values are there. Many missing values are there. And for handling the missing values, we have used this much. For the categorical columns, we have done .mode. Mode is used that in the columns with the
For filling the numerical data, we have used a mean value. For filling the categorical data, we have filled with a mode value.
And the columns which are not required, we have dropped it. This is used for dropping the rows which have any null values. We have only some rows are dropped. It will not affect our data set more.
So this is a statistical summary of our training data, which counts the number of features and gives the mean value, standard deviation, and minimum and maximum of the particular features. Cleaning of test data. So we have a separate file called test data and the train data. Here we have uploaded test data to clean it. So the shape is 1459 and 80 columns. So these are the null values. So here also we have filled categorical data with the mode and the numerical data with the mean. And finally it gives the shape as 1459 and 78 columns.
Then we have done exploratory data analysis. This code is used for finding the columns which are mostly correlated with the sales price. You can see that these are the columns: overall quality, year build, year, remote ad, and these other columns are there which are more correlated with the sales price: 0.79, 0.52, 0.50, 0.61, and so on. and this is used to find for the 1 lakh. This is the sales price, number of houses which are available in our data set. These are the count of the number of houses available in our data set. And these are the 4 columns which are positively correlated with each other. You can see that sales price, overall quality, sales price and sales price we have found on the count there.
Next is one hot encoding of categorical data. So in our data sets there are numerical data as well as categorical data. So in order to convert this categorical data into numerical data, we have used a method called one hot encoding. Those are the columns which are categorical data. Next we have used this method. And we have finally converted.
We pass the function here for the columns which have categorical data, and it gives converts that categorical data into numerical values. And here we have dropped the after one hot encoding, we have got the shape as 244, and we have removed the duplicated columns and got shape around 180 columns. Then we have concatenated our data, train data and test data. Then we have splitted our data into train data and test data different. Then we have dropped the sales price from the test data because all the null values are there in test data. Parameter optimization, there are different parameters. This randomized search CV will pass the set of parameters and will search the best parameter which will give the best accuracy for our model. And from here we have find the best estimators. Like for base score is 0.575, boost is GB3, and the minimum child weight is 2, max depth 5, and we have copy pasted this here to as the parameters to make our model with the hyperparameter optimization. Then our accuracy got increased by 92%. Increased, and we got the accuracy as 92%, and root mean square is decreased, and we got around 24,000.
Next we are predicting the model based on separate data set, that is a test data set. So here we have uploaded test data set. So we are predicting the sales price of the house. So these are the sales price of the house, those prediction values.
This all there are around 59 rows. Then we have deployed deployment of our data in a web page. We have installed the Streamlit. These are the code with the same parameters which we have done in hyperparameter optimization. We got the best parameters, and this is the code to run our Streamlit web page. One hot encoding. This is a data frame preview. We can enter all our data manually here. So many wisdom, if you predict it. I have not entered the values here. It's so many values. It will consider it as 0, and we can predict our price as 44. 4,41,000.